All right, so we're going to start off with 227, number 25, and I see here that they want me to solve this equation. Now notice here it actually says determine an exact value for C. Okay, so that implies that there could be more, and anytime you've got trigonometric equation, you should probably, it's a good chance that there's going to be not just one or two solutions, likely infinitely many solutions. Okay. Now, while this is not exactly like the one that we saw in class, you hopefully realize that if you bring one of these two expressions to the other side of the equation, you're going to get something that looks like one of our correlated angle identities. Okay, so which you bring to the right or the left. I guess I'd be tempted to bring the cotangent to the right-hand side, just because it then matches exactly what we have in the in our formula sheet. Okay, so that's going to be my first step here, is to realize that by bringing one to the other side, I get something that looks familiar to me. Okay. Okay, so this is where I now go to my trusty formula sheet and I try to find scenarios where I have a tangent value that's the negative of a cotangent value. So I'm going to write those on the side. So here, my first option that I see is I've got tan of pi over 2 plus theta is going to be equal to negative cotangent of theta. Okay, now again, if we kind of looked at it geometrically, if you think of theta as being in the first quadrant, kind of makes sense, because tangent in the second quadrant, I think pi over 2 plus theta is negative, so they won't have the same sign. And the other scenario, okay, it not surprisingly should be in the fourth quadrant, where again, tangent is going to have a different sign in the fourth quadrant than it does in the first. So we have that tan of 3 pi over 2 plus theta is equal to negative cotangent of theta. So remember here, you don't have to memorize these. They're given to you. Okay, but what this does is it gives us a scenario where tangent value is equal to the negative of the cotangent value, and they have to be equal to each other because these are identities. All right, so this is where, I might as well do both, but they really only asked for one possible solution. But if I use identity 1, I say, well, if I let theta be equal to this value here, 4c minus pi over 4, then I know by choosing the input of tangent to be pi over 2 plus theta, then these two sides will have to be equal based on our identity. So here we just make 2c plus pi over 4 equal to pi over 2 plus theta. And then we have the equality guaranteed. But essentially what we've done is we've created now a system of equations. So now I'm just going to replace theta by 4c minus pi over 4, and that gives me something I can actually solve for. And here, 4c minus pi over 4. Notice here there wasn't really a need for me to put brackets because it was an addition, but because I want to make sure that I get used to doing it all the time in case it was a subtraction, I forced myself to do it in all circumstances. Okay, so here I hope everybody's taking a close look at my algebra so I don't make any silly mistakes here. So let's bring the 2c to the other side so that we're left with 2c. And then what are we left with? Well, we're left with pi over 4. And then here, we're going to be plus pi over 4. And then here, minus pi over 2. Okay, so it looks like one possible scenario, okay, is that we have pi over 4 plus pi over 4 is exactly equal to pi over 2 minus pi over 2 is 0. Okay, but that's just one possible situation. Okay, if I wanted to look for, even though they didn't ask me for it, if I want to look for another answer, I can now use this second identity here. So what do we got here? So again, I'm going to let theta be equal to 4c minus pi over 4. And then in this case here, the 2c plus pi over 4 will be assigned to 3 pi over 2 plus theta, and that's going to guarantee the equality. Okay. So again, system of equations, 2c plus pi over 4 equals 3 pi over 2 plus theta 4c minus pi over 4. And now here, let's do our solution. So what do we got? Again, 2c to the other side should give us 2c. And what do we have here? We have pi over 4, okay, plus pi over 4, and then here minus 3 pi over 2. Okay, and so what does that give us? 2c equals, so again, this is going to be pi over 2 minus 3 pi over 2. And what does that give us? So this gives us, I guess, negative 2 pi over 2, which of course is just negative pi. So it looks like negative pi over 2, if I did all my arithmetic correctly, would be another possible solution. Okay. Now, of course, you can always check these, by sticking in the c value. In this case here, for c equals 0, you can actually do that with your without your calculator. Maybe this one here, you could also figure it out without your calculator. But what you can always do is just stick it in to the left-hand side, right-hand side, even with your calculator. Make sure your calculator's in radians, and you can test that this does indeed give you an equality there. Okay, yeah, Elliot, question?
I'm still a little confused on how you derive the system of equations.
Yeah. So let's review that. Okay. So here you're looking for c values that are going to make these two sides equal. Okay. That's what it means to solve an equation, is to find the values of the variable that solve the equality, that make these two sides equal to each other. Okay. Well, it just so happens that if I take the input of cotangent, okay, and then the input of tangent is pi over 2 plus the input of cotangent, then the two sides have to be equal. So what I'm using here is the idea that this identity is something that's been proven, that whatever the value for, whatever the input for cotangent is, as long as the input for tangent is pi over 2 plus that value, then these two sides are necessarily equal. So does that make sense? That idea that this is what an identity means. Perfect. So here, I want to find out when these two sides are going to be equal. So this is an identity, so it's true all the time. I just happen to pick theta to be 4c minus pi over 4. So if the input to tangent is pi over 2 plus that input, then these two sides must be equal. And I get that from the identity. So that's how I set up my system of equations, is I choose theta, okay, the input to cotangent, to be whatever the input is here. I can do that since it can be any input at all. And then what the identity tells me is if the input to tangent is pi over 2 plus that angle, then these two sides are automatically equal to each other. And that's how I end up with this system of equations. Okay.
Okay, thank you.
And what's interesting with, like, again, what I don't want us to lose here is this is a completely different way of thinking about how we solve an equation, right? Or a system of equations. We always think about solving an equation as performing a set of operations, whether it be something like factoring or using opposite operations. This is a very different way to think of how to solve an equation. It's because normally you don't have some identity that relates exactly to the equation that you have. This is kind of a new scenario for us here. Okay, so it definitely is a bit of a subtle idea, but that's how. And of course, I repeat the exact same argument. Okay, it's that this identity, as long as this relationship exists between the input of cotangent and the input of tangent, guarantees that the two sides are going to be equal. Okay, and again, this allows me to get two answers. Okay, any other questions on this one here? No, okay. If not, let's go on. And I know someone had asked something else on email, except it was likely there must have been an error. Okay, page 24A on page 235. Okay, that makes sense. So unless there's anything else, I'll go to page 235, 24A. Okay, so page 235, number 24A. And let's see what that entails here. 235. So this says derive the half angle formula for sine, so sine of x plus 2. Okay. Now, I don't remember if I had written that on it as a hint, is that this is very similar to what we did in class. So let's recall what we did in class. What we did is we found a way to determine the exact value of sine of pi over 8. Okay. But how did we think of pi over 8? We thought of it as being half of pi over 4. Okay. And so this gave us a way to determine the exact value for sine of pi over 8. Okay. But if you remember correctly, when we actually came up with the formula, wait, I need to make sure my device does not restart. There you go. What was I talking about here? Oh, equals pi over 8. Okay. The way in which we set it up is we wrote pi over 4 as 2 times pi over 8. Okay. So what we're going to try to do is essentially come up with a formula. And if you happen to look at the lesson sheet, well, guess what we're going to do in class tomorrow? We're going to come up with a formula for cos of x over 2. Okay, so here in the homework, we'll get some practice of doing sine of x over 2. Okay, so what we have here is we need to set up inequality like we did here. Okay, so that we can come up with 2 times an angle. And what we're going to do is we're going to say that some generic angle x, in our specific example, x was pi over 4, can be written as 2 times, well, pi over 8 is half of pi over 4, 2 times x over 2. Okay, so I think this is clearly, obviously a true statement if you reduce the right-hand side. But where did I come up with this? I didn't come up with this, out of thin air. Is I'm relating it to the example we did when we were coming up with a formula for pi over 8, which is half of pi over 4. So we use this specific example, okay, using a special angle to inspire our starting point for a more general proof, okay? And what did we do last time? Even though we were looking for sine of pi over 8, we did not take sine of both sides. Now, can somebody remember why we didn't take sine of both sides? Why did we take cosine of both sides, even though we're looking for the sine value? I'm just curious to see, does anybody remember why taking sine of both sides doesn't work? And think about the double angle formula for sine. What does it possess that makes it kind of unusable in this situation? Any takers? Well, let's write out the double angle formula for sine. The problem with this one here is it contains both the sine of the angle theta, which is going to be our x over 2 here, and the cosine of our angle, which is x over 2. And that's not very helpful to have both of them, okay? But the cosine double angle formula, in particular, there's one of the 3 that only contains a sine value as part of its expression, okay? Wait, somebody's just coming in, okay? So, like I said, I didn't come out for this nowhere. I'm using the inspiration that we had when we were looking for pi over 8. But now what I'm going to do is I'm going to take cosine of both sides. Okay. And by the way, just so that we know what we're trying to show here, I guess I should have written it out, is we're trying to show that sine of x over 2 is equal to plus or minus square root of 1 minus cos x over 2. This is what we're trying to prove. Okay. So cos x, I'm very happy that it's there because it's one of the things that I expect to find in my formula. But now what we have to do is we're going to have to generate this sine of x over 2. So this is where now I'm going to use this identity on the right-hand side. Okay. So we know that based on our double angle formula, this can be written as 1 minus 2 times sine squared of, this is like my angle theta here, the x over 2. And now in my equation, I'm going to be able to isolate the sine of x over 2. And that's what's going to give me my formula. Okay, so now I'm going to do what I did last time. You know, I don't like having this negative in front, so I'll bring the 2 sine squared to the other side. Here I'm going to have 1 minus cos x, and we sort of see it's starting to come along very nicely. Then I'm going to divide by 2. And now lastly, I'm going to take the square root of both sides. Okay, but in taking the square root, I realize that I can take both the positive or the negative square root. And what we've done here is we found our formula. Okay, but of course, the sine of any angle can't have 2 answers. There's only one sine value. You know, you only have, you know, with regardless of what x, y, and r you use on the terminal arm, there can only be one value. So what should we be adding here as a little extra piece of information? What should I be saying about this plus or minus? Come on, folks. I'm sure someone here can help me out with that. What is going to determine whether I'm going to choose the positive square root or the negative square root?
The quadrant.
Exactly. Whatever quadrant x over 2 is in is going to determine whether we take the positive one. So in class, when we were doing pi over 8, we chose the positive square root because pi over 8 is in the first quadrant. Okay. So here I'll just say the sine SIGN, sorry, okay, will depend on the quadrant of x over 2. Okay, so if x over 2 is some angle in the first or second quadrant, you'll be taking the positive square root. And if x over 2 is some angle in the third or fourth quadrant, you're going to be taking the negative square root. Okay, so here, keep in mind, because the one you're going to be doing in class right away on Monday, the first question we're going to do will be very similar to this, except you're going to be looking for a half angle formula for cosine. Okay, but the whole strategy is going to be very, very similar. Okay, any other questions on this one here? No? Okay. So this again, this is a really nice example of how sometimes working with a specific example can actually inspire a proof. Okay, we, you know, solved this problem for finding just pi over 8, but we were able to follow the exact same steps to come up with a formula that works for any half angle now. Okay, so those are the 2 questions that were sent to me earlier on. If there's nothing else, we'll end it there. Or if somebody's got any other questions, now's the time. Just going to look back here, see if there's anything that 23, page 226. Yeah, we can do that. Again, I think there's videos on these. We can do those, can do that, but let's There's one other, I guess I'm a bit surprised nobody asked about. Okay, 15 on 233, we're okay with that one. Okay, maybe check, but okay, so let's do 23 on page 226. Okay, so this says, okay, and I'm going to ask, I don't remember if I asked for all parts of this, but here it says determine an exact value for the angle A such that secant of A is equal to cosecant of 3A. All right, so this page 226, number 23. Okay, I think in their BC, they're trying to give you a sort of a hint on how to do it. So I'm just going to go ahead and do it similar to the way we did it there. Okay, so here secant of A equal to cosecant of 3A. So again, here, likely there are infinitely many values of A that are going to make this equation true. Okay, they're asking us to find one, but since we're at it, we've been doing it so far. Let's find two of them just so that you can see the. Now, what I see here is two equal trig ratios, but not the same trig ratio. So I should be thinking correlated angle identities. Problem is when I look on my formula sheet, I don't see something that directly connects secant and cosecant. But what can we see on our formula sheet that will help us with secant and cosecant? And I think we talked about this very briefly. The identity that's going to help us is there. It's just not given directly. So think secant. What trig ratio is related to secant? Yeah, anybody?
1 over cos theta.
Yeah, you realize that secant is just the reciprocal of cosine, and cosecant is just the reciprocal of sine. So if I take the, take the reciprocal of both sides, okay, which I'm allowed to do as long as I perform it, essentially what I get here is I just get that cosine of A is going to have to be equal to sine of 3A. Okay. So essentially, this is not cosine of, sorry, cosine of theta is going to be equal to a sine value. So you know what? I think the easiest thing for me to do is to actually show sorry, that was what I said here. Is it correct? I'm trying to go a bit fast here. What I'm trying to do is I'm trying to find an identity that fits this, and this is going to be cosine and sine. And so what are the identities that relate a cosine value and a sine value? Sorry about that. Hopefully it's not too confusing now. And what I see on my formula sheet, as I see that cosine of pi over 2 minus theta is equal to sine of theta. There's one of them. Okay. And if I take the reciprocal of this, what do I get? I get, well, 1 over cosine is just secant of pi over 2 minus theta. And the reciprocal of the other side is cosecant of theta. So this would be a valid identity that's going to help me solve this problem. And if I look around, I see, another identity that involves a cosine equaling a sine value. And that's this identity here. And if I take the reciprocal of both sides, what do I get? Secant of 3 pi over 2 plus theta is equal to cosecant of theta. So this is going to be another identity that I can use to help solve the equation. Okay, sorry about the little snafu there. So now I'm going to do exactly what I did before. Okay, Theta can be anything. I'll use this one here. I'll call this number 1. I'll call this number 2. Okay. So if I look at number 1, again, I'm going to make the same argument as before. Theta can be any angle. I'm just going to let it be equal to 3a. Okay. And I know that if the input to secant is pi over 2 minus theta, then the two sides must be equal to each other. So a is just going to be equal to pi over 2 minus theta. Okay. And this again sets up our system of equations as we saw before. So again, just to repeat what we're doing, we're saying I'm choosing theta to be 3a, and the identity tells me that if the input to secant is pi over 2 minus theta, so if a is equal to pi over 2 minus theta, then I'm guaranteed that these two sides are equal to each other. And that's what I'm looking for, is a values that make the two sides equal. And so now, like before, I do a little substitution. So here I have a equals pi over 2 minus 3a, and now I can solve this. Okay, so bring the 3a to the other side, so it's 4a equals pi over 2, divide by a, I get pi over 2 times 4 is 8. Okay, and now if I want a second answer, okay, I can just use now the second identity. Okay, so if I want a second answer, again, I'll let theta be equal to 3a. And now here, the input to secant, I'm going to let equal to 3 pi over 2 plus theta. Okay, and again, we set up our system of equations. So a is equal to 3 pi over 2 plus, now I'm just going to replace again theta by 3a. Okay, except now I think I'm going to bring the a to the right-hand side to give me 2a, bring that to the left-hand side, negative 3 pi over 2. And so a will just be equal to negative 3 pi over 4. And there's another possible solution. Okay. So we're starting to see, you know, a pattern in solving these types of equations. Okay. And again, if you need another look at these, there's, I think, videos for both 23 and 25 on the YouTube channel. Okay, is there anything else? Or any questions on this one here? Okay, if there's no other questions, then we'll call it a night, and we'll see you folks all tomorrow.